Good afternoon, my name is Alan.
I'm Harry.
I'm Jackson.
I'm Matthew.
I'm Adrian, and we're group B08, and this is our video presentation for Project 2. Our coin-picking robot had to meet the course's requirements. It had to be controlled by a remote controller, also have an autonomous mode, and the remote and the robot had to use different microcontrollers. Design of the robot is heavily based on the figures shown on the slide set, and consists almost entirely of parts from the project kit. We bent the chassis in place and installed the parts as shown in the figure. It was decided that the robot would get the EFM84 chip, while the remote would get the ATM328P. For our hardware design, the robot system was composed of multiple functional components. The robot chassis motor drive, microcontroller, metal and perimeter detectors, wireless radio communication, and coin-picking mechanism. Each subsystem was designed by applying principles of embedded systems, AD design, circuit design, and power management. We could not fit all the electronics on one board, so we had to install a second breadboard on the robot using duct tape. Software design consisted of two main parts. The first part was the slave code, which consists of servo control, sensor integration, movement control, coin picking mechanism, wireless communication, automatic mode logic, and manual mode logic. The second part was the master code. Master code included joystick-based control and toggle mode for automatic mode, JDY40 communication, speaker feedback, and LCD feedback. Challenges and improvements. One of the biggest challenges when building and testing our robot was getting its autonomous functionality to work. The robot experienced many false positives, falsely leading itself to believe it had picked up a coin. This could only be reworked by improving the pickup sequence to be more effective at sweeping a coin. We also experienced false negatives when the robot voluntarily stopped and initiated a pickup sequence despite there being no coin. This was resolved when we added a function to recalibrate the ambient frequency of the inductor after every successful pickup.
That's going to be a perfect sweep there. No! Yep, that is a pass.
Okay, I'll take that.
That's all. Let's do manual mode.
Our team struggled with manual control with the joystick all throughout the project. The joystick in the project kit had faulty internals and would often confuse the microcontroller due to stick drift. The faulty radio only added to the challenge where the robot would keep acting on an outdated command. We also borrowed the same parts from another group, and that helped our robot run smoother. There was a consideration to implement a graduated speed control system using the joystick, but this idea was deemed too costly on memory, and we couldn't find a way to add it while preserving robot functionality.
Sweep, stick, drop.
One improvement we made was using our own bigger washer on the coin-picking arm inductor. We made another improvement to the robot in the form of two IR sensors. The The IR sensors were connected to the robot's EFM8 ADC pins and worked alongside the existing perimeter detector. Since our field was made of white shelf liner and our perimeter duct tape, this made it easy for the IR sensor to distinguish light from dark, field from perimeter. To sum up, although our project encountered numerous challenges as we worked, ultimately we were able to demo a fully functional project. There were many features that couldn't fit due to hardware and processing limitations, but this project was pretty successful and was a great learning experience for every one of us.